All right, let's talk about maximizing revenue. I manage a band called the Logarithms. They have an upcoming performance, and we are selling tickets at $12 per ticket, and we will sell 1,500 tickets, which fills the entire venue. So let's talk about the current revenue. All right, we know revenue is price times quantity, and our quantity is 1,500 tickets. So that is a revenue of $18,000 currently. All right, we want to see what we have to do to maximize our revenue, but we will not lower the price. So what if we raise the price? How is that going to affect our ticket sales and our revenue? All right, so let's say if we raise if we raise the price by 50 cents per ticket, then what's going to happen? So every 50-cent increase lowers ticket sales by 50 tickets. Okay, so the revenue then would be 50-cent increase would be $12.50 per ticket. And instead of selling 1,500 tickets, we're selling 1,500 minus 50. So we would only sell 1,450 tickets. Which gives us a revenue of $18,125. So the revenue did increase. So basically, what's the optimal amount of 50-cent increases that we should make so that we will get the maximum revenue? Because there's got to be a point when we've increased it too much. Okay, so let's talk about this then. Okay, let's go back and let's talk about revenue. And remember, we know that revenue is the selling price times the number of tickets sold. That's how we figure out our revenue. All right. And so instead of talking about what the price is, we're going to talk about the number of 50-cent increases. So I'm going to say let X be the number of 50-cent increases in price. All right, so let's come up with a function for revenue based on X. So revenue function of X. All right, so we, if we're currently at $12 per ticket, and we're going to increase it by 50 cents a certain number of times. So it'd be 50 cents times X. Okay, and we're currently at 1,500 tickets sales. And what happens to the ticket sales if we increase the price? It decreases by 50 tickets for every 50-cent increase. So that would be 50x. So both the price and the number of tickets sold is based on this number of 50-cent increases in price. All right, now what are our restrictions on X? Let's talk about what X can be. Well, we know it has to be greater than 0, and it could be 0. If it's 0, then we know we're back to a revenue of $18,000. But what is the maximum number of 50-cent increases? Well, we have to think about tickets sold. And this is going to tell us how many tickets we sell. Well, we don't want the number of tickets sold to be 0, right? Or whatever makes it 0, that's the highest we should go. So 1,500 minus 50x, what's going to make that 0? Ticket sales. So we end up with 30. So basically, the maximum number of 50-cent increases should be 30, which would basically jack the price up so high that we would sell more tickets. All right, so now we need to find, we're talking about maximizing revenue. All right, so we have to find the critical point on that interval. So I think it would be easier to find the derivative if we multiplied this out. Otherwise, you could use the product rule, but I think we're better at least I am anyway, finding derivatives of polynomial functions. So if you would distribute, or call it FOIL if you will, combine like terms, you're going to end up with your revenue function. I'm going to go ahead and distribute. And then I'll combine like terms, and I'll go ahead and put it in descending order. All right, so here is my revenue function based on, it'll calculate the revenue based on the number of 50-cent increases in price. Okay. So we want to maximize revenue. All right, so we need the derivative. Critical point. So the derivative is negative 50x plus 150. Critical point is what makes it equal to 0. So if we solve for x, we get x equals 3. So our critical point is 3. And then, of course, we have to test because we're trying to find the maximum value on a closed interval. There it goes. So we will test the endpoints and the critical point. So calculate the revenue for each of those values. So the revenue for 0 increases in ticket price, and the revenue for 30, 50-cent increases in ticket price, and then we want the revenue for 3. So we substitute all of those back into we substitute these back into our revenue function right here. And we get, if there's 0 50-cent increases in price, we're at our initial revenue of $18,000. If there's 30, we're at $0 because we wouldn't sell any tickets. And if we put 3 in, we basically get, let's see here, $18,225, which happens to be our maximum value. Okay, so we checked it at our end points. That section 4.3 keeps coming back, and our critical point. Okay, so what was the question? What ticket price maximizes revenue? Okay, so what's the ticket price? Well, it's $12 initially plus 50-cent increases. Well, we know that we're going to have 3 50-cent increases, which is $1.50. So we should sell tickets for $13.50 to maximize profit. Revenue, excuse me. $18,225. Now, one comment here. This is very much like, well, it's pretty much exactly, I guess, 21 and 22 on page 201.